Asynchronous programming is a powerful feature in C# that allows you to write code that doesn't block the execution of your program while waiting for tasks to complete. This lesson will introduce you to the async and await keywords in C#, enabling you to implement asynchronous methods effectively. Don't worry if this feels new at first. Now we're on understanding asynchronous programming. Asynchronous programming is designed to improve the responsiveness of applications. In traditional synchronous programming, methods execute sequentially, meaning one method must finish before the next one starts. This can lead to performance bottlenecks, especially when dealing with I/O operations like file reading, web requests, or database queries. In contrast, asynchronous programming allows methods to initiate tasks and then continue executing other code while waiting for those tasks to complete. This is particularly useful in applications that require a user interface, where you want to keep the interface responsive while performing time-consuming operations in the background. Defining async methods. Let's dig in. To define an asynchronous method in C#, you use the async modifier in the method declaration. This tells the compiler that the method will contain asynchronous operations. The return type of an async method is typically task or task. If the method doesn't return a value, you can use task. If it returns a value, you use task, where t is the type of the returned value. Next, using await. The await keyword is used inside an async method to indicate that the method should pause execution until the awaited task completes. This allows other tasks to run in the meantime, keeping the application responsive. This section covers implementing an asynchronous method. Let's create a simple example to demonstrate how to implement an asynchronous method using async and await. In this example, we will simulate a time-consuming operation that fetches data from a web service. You'll use this often as you go. The class shown on screen and how its members are organized. In this code, first, the main method is marked as async, allowing it to use the await keyword. Also, the fetch data from web service async method is defined to return a task, indicating it will return a string asynchronously. Also, inside fetch data from web service async, we use a wait task, delay 2000, to simulate a delay, representing a long-running task. Finally, we then use a wait client.getStringAsync to fetch data from a web service asynchronously. In this lesson, we learned about asynchronous programming in C# and how to use the async and await keywords to implement asynchronous methods. By defining methods with the async modifier and using the await keyword, you can ensure that your applications remain responsive while waiting for long-running operations to complete. Go ahead and work through this exercise. First, modify the fetch data from web service async method to fetch data from a different URL of your choice. Also, add error handling to your asynchronous method to manage potential exceptions that may arise during the web request. Also, implement another async method that fetches data from multiple URLs concurrently using task.whenAll. Finally, create a simple console application that allows the user to input a URL and fetch data from it asynchronously.